Good morning everyone. My name is Clarence J. Canton from second year BSME and my topic today is basic measuring. Measurements and measurement system are today's most important and useful topics for learn and discuss and identify. So, in order to take perfect measurements, we need to measure correctly and for that we must know the measuring procedure and measuring system. Definition of measurement. Measurement is finding a number that shows the size or amount of something. System of measurement. There are two main systems of measurement in the world. This is the metric or decimal system and the US standard system. In each system, there are different units for measuring things like volume and mass. Metric system of measurement. The metric system is a system of measuring. It has three basic units. M, the meter for length, kg, the kilogram for mass, s, the second for time. All the other units are derived from these three basic units. US Standard System. United States Standard System is a system of measurements commonly used in the United States. The US Standard System developed from English units which were in use in the British Empire before American independence. International System of Units. The modern form of the metric system is known as the International System of Units and is the most widely used system of measurement. It comprises a coherent system of units of measurement built on 7 basis units. This is meter for length, kilogram for mass, second for time, ampere for electric current, Kelvin for temperature, candela for luminous intensity, mole for amount of substance. We can measure many different things, but mostly we measure length, area, volume, mass, and time. Length, distance from end to end. Area, the extent of measurement of a surface. Mass is the measure of how much matter is in an object. Volume, the amount of space, three-dimensional, that an object or substance occupies. Time, the indefinite continued progress of existent and event in the past, present, and future regarded as a whole.
Morning leaders, now let us proceed to layout. So, what is layout? The layout of an operation or process means on how to transform a resources are positioned relative to each other and how its various tasks are allocated to these transforming resources. So, the types of layout: number 1, product layout; number 2, process layout; number 3, fixed position layout; number 4, cellular layout; and then number 5, combination layout. So what is product layout? Also known as line or flow line layout. If all the processing equipment and machines are arranged according to the operations of the product, the layout is called product layout. And then the process layout, also known as job shop or functional layout. The process layout is particularly useful where low volume of production is needed. If the product is not standardized, the process layout is more low desirable because it has greater process flexibility than others. And then the fixed position layout. This type of layout is the least important for today's manufacturing industries. In this type of layout, the major component remain in a fixed location. Other materials, parts, tools, machinery, manpower, and other supporting equipments are brought to this location. So what is a cellular layout? It is a type where machines are group according to the process requirements for a set of similar items that require similar processing. And lastly, the combination layout. Many situations call for mixture of three layout types. These mixtures are commonly called combination or hybrid layout. That's all. Thank you.
Good morning, leaders. This is Asis Panyor reporting for metric system. What is metric system? The metric system is a measurement system based on our decimal base 10 number system. Other countries and all scientists and engineers use the metric system for measurement. This is metric prefixes. Prefix Exa, peta, tera, giga, mega, kilo, hekto, deka, deci, sintri, mili, micro, nano, pico, micro. Place values of metric prefixes. Thousand, hundred, ten, one, ten, hundred, thousand. Meters. 1 centimeter is about the width of a large paper clip or your fingernail. A meter is about the width of a doorway. A kilometer is about 6 city blocks or 10 football fields. Kilometer is about 1 mile. Grams. Grams are used to measure mass or the weight of an object. A milligram weighs about as much as a grain of salt. Gram gram weighs about as much as a small paper clip. 1 kilogram weighs about as much as 6 apples or 2 pounds. Liters. Liters measure liquid or capacity. 1 millimeter is about the amount of 1 drop. 1 liter is half of a 2 liters bottle of Coke or other soda. Kiloliter would be able 500 to 2 liter bottles of pop. That's all. Thank you.
Hi, I am Mark Antonitano, and for this video report, I will discuss metrology. So first, what is metrology? Metrology is the scientific study of measurement or the science of measurement embracing both experimental and theoretical determination at any level of uncertainty in any field of science and technology. An example of the type be seen in production of products for the commercial industry, testing designing of aircraft, factories using rotating equipment during the manufacturing of their products. So next, definition of metrology. Field of knowledge concerned with measurement and includes both theoretical and practical problems related to measurement. Process of making extremely precise measurement. It is the documented control that all equipment is suitable, collaborated, and maintained in order to perform its function and give reliable results. The science concerned with the establishment, reproduction, and transfer of units of measurements and their standards. Next is principal field of metrology and its related fields. Establishing units for measurement and their standards. Measurements, methods, execution, and estimation of their accuracy. Measuring instruments, properties, examined with respect to their intended purpose. Observers' capabilities with reference to making measurements. Design, manufacturing, and testing of gauge of all kinds.
Type of metrology. First, scientific metrology. It deals with the organization and development of measurement standard and with their maintenance at the highest level. Second, industrial metrology. It deals with the ensuring of the adequate functioning of measuring instrument used in industry as well as in production and testing process. Third, legal metrology. It is a concern with the accuracy of measuring where these have influence of the transparency of economical transaction and health safety. Fourth, fundamental metrology. It will be described as a scientific metrology, supplement by those part as legal industrial metrology that requires scientific component. It, it is divided accordance with the following 11 fields: mass, electrical, length, time, frequency, ionizing, radiation, radioactivity, photometry, radiometry, flow, acoustic, amount of the substance, and interdisciplinary methodology for inspection. First, to ensure competence and parts conform to the established standard. Second, to meet the interchangeability of manufacturer. Third, to provide the means of finding the problem areas. Fourth, to produce the part having acceptable quality level. Fifth, to judge possibility of rework of defective parts and re-engineer the process. Last, to, to, pur- to purchase good quality raw materials, tools, and equipment.